Automotive brake systems are crucial safety components in vehicles that enable drivers to slow down or stop their vehicles effectively. These systems use friction to convert the kinetic energy of a moving vehicle into heat energy, which is dissipated into the surrounding environment. There are several types of automotive brake systems, with the most common ones being disc brakes and drum brakes. Disc brakes are widely used in modern vehicles and are more efficient at dissipating heat compared to drum brakes. They consist of a brake rotor, disc, attached to the wheel hub and a brake caliper that houses the brake pads. When the driver applies the brake pedal, hydraulic pressure forces the brake pads against the rotating disc, generating friction and slowing down the vehicle. Advantages of disc brakes: better heat dissipation, reducing the risk of brake fade. Generally provide better stopping power. Easier to cool, making them suitable for high-performance and heavy-duty applications. Can be more expensive to manufacture and maintain compared to drum brakes. Susceptible to corrosion in certain conditions. Drum brakes are older technology and are often used in the rear wheels of vehicles. They consist of a brake drum attached to the wheel hub and brake shoes housed inside the drum. When the brake pedal is pressed, hydraulic pressure pushes the brake shoes outward against the drum, generating friction and slowing down the vehicle. Advantages of drum brakes: simpler design and construction, which can lead to lower manufacturing costs. More enclosed design, reducing exposure to the elements and corrosion. Less effective at heat dissipation, which can lead to brake fade during heavy use. Generally provide lower stopping power compared to disc brakes. Can be more challenging to service and adjust. Anti-lock brake system, ABS. ABS is a safety feature designed to prevent wheel lock-up during hard braking. It modulates brake pressure rapidly to prevent skidding, allowing the driver to maintain steering control while braking. ABS systems use sensors to monitor the speed of each wheel and adjust brake pressure accordingly. Electronic Brakeforce distribution, EBD. EBD is a system that optimizes brake force distribution between the front and rear wheels to ensure effective braking regardless of the vehicle's load distribution. It improves stability during braking by preventing the rear wheels from locking up prematurely. Brake assist. Brake assist systems detect emergency braking situations and apply maximum braking force to help the driver stop the vehicle as quickly as possible. Regenerative braking. Common in hybrid and electric vehicles, regenerative braking captures and converts kinetic energy back into electrical energy to recharge the vehicle's battery. This can increase overall efficiency and extend the vehicle's range. Brake systems require regular maintenance to ensure proper function and safety. This maintenance includes checking brake fluid levels, inspecting brake pads and rotors for wear, and addressing any issues promptly. Always consult your vehicle's owner's manual and a qualified mechanic for proper maintenance and repair.